Hello students, today our question is the work function of a silver and sodium are 4.6 and 2.3 electron volt, and we have the ratio of the slope of the stopping potential. We have to find the ratio of slope of stopping potential versus frequency for the silver to that of sodium is. So the solution of this question is, we know that h nu, that is the Planck's constant, into frequency is equals to phi, that is our work function E, and V naught, that is our stopping potential. So from this we can write here h divided by E, and this is nu, that is our frequency, and this is phi divided by E, that is work function divided by E, and this is V naught, that is stopping potential. So from this we get V naught, that is our stopping potential, is h divided by E, multiplied by nu, that is our frequency, and this is phi divided by E here. So from this we can say that slope is h divided by E. So firstly we draw the slope here. So this is our x-axis and this is our y-axis. So in this is our negative y-axis and this is our negative x-axis. So we have here, we have the frequency nu and this is stopping potential. So our graph is like this. So if we compare this equation, so we get this is equals to y is equals to mx. So from this we have this is equals to m, that is our slope. So we have to take the slope of silver and this is divided by slope of sodium, that is Na. So this value doesn't change for the material. So we can write here this is h divided by E and this is h divided by E. So this is h divided by E. So from this we get this is equals to 1. So the ratio is 1. Thank you.
So here the question is, the maximum kinetic energy of electron emitted in the photoelectric effect is linearly depend on the dash of the incident radiation. So first let's understand what is photoelectric emission. So let's suppose this is a plate of metal plate having some electrons, okay, and some radiation were incident on this plate. Okay, so the incident radiation have the frequency is h mu. Okay, let's suppose this, and the electron will be ejected when the radiation is incident on the surface of metal. Okay, so this electron will comes in kinetic energy when it moves away with the incident radiation is coming, and this energy is called here is threshold frequency, is h mu naught. Okay, so in this case we can say that from using the energy of conservation, for using energy conservation, we can say that the radiation of the incident ray, which is h mu, is equal to what? The threshold frequency of the electron plus the kinetic energy of the electron is equal to h mu. H mu is the threshold frequency. It means it is the minimum frequency which is required to eject the electron from the surface of metal. Okay, so plus kinetic energy. So here in the question, the maximum kinetic energy of electron emitted in the photoelectric effect. So when the kinetic energy is maximum, then what will be its depend? Then the incident radiation is depending on what? So when the kinetic energy is maximum, it will be equal to h mu naught, which is very low, and here is the frequency of incident radiation. So it will be so it will be very low, then we will not consider this threshold frequency. Here we only consider the frequency of radiation which the maximum kinetic energy is depend. What is this? The frequency of incident radiation. So in the blank, so the photoelectric effect is linearly depend on the frequency of the incident radiation. Okay, that's it. Thank you. Here the question is, in a photoelectric effect emission, the process of maximum energy of a photoelectron increase with increasing intensity of the incident light. So we have to find this statement is true or false. First, let us know the electron's energy. The maximum energy of photoelectron is what? So the electron having the maximum energy when the electron is come out from the surface of metal with the help of incident light, and the maximum energy of the electron here is converted into the kinetic energy of electron, which is K maximum, is equal to h mu minus h mu naught. This equation is given by the Einstein photoelectric equation. This equation is known as Einstein photoelectric equation. So here the h mu is the frequency of incident radiation, and h mu naught is the frequency, or we can say threshold frequency. And the threshold frequency is the frequency that is required to come out the electron from the surface of metal. Okay, so here we conclude that the maximum kinetic energy is proportional to frequency of incident radiation and not to intensity. Okay, so this equation is, so this statement is false. Okay, that's it, because the intensity is non-dependent of the energy of photoelectrons. It depends on the frequency of the incident radiation. That's it. Thank you.